Bismillahirrahmanirrahim. In this video, I will explain how to determine the value of X at zero shear force. The process is very simple and straightforward, especially for the beam having a uniformly distributed load. And we have a beam which is 5 meter, and it's a simply supported beam. We have 10 kilonewton of per meter UDL and a 5 kilonewton point load at a 3 meter of distance. So we are already done with the reactions at both of the ends. One AY is equal to 23 and BY is equal to 12. First of all, I will draw the shear force diagram for the given beam. Shear force. So here we have 0. The process is very simple. So we will start from, we have 23. So we will go up 23. So 23 minus 10 multiplied by 330. So 23 minus 30. This is minus 7. So here we have minus 7 and minus 5. So minus 12. Minus 12. And here we have plus 12. So we'll go back to 0. Since we have, as you know, we have a UDL, so the degree of the line will be first degree. So we will draw it. And we'll go back to 0. Okay. So minus, minus and plus. So the point, the main focus will be on finding this X. So we are finding this X. So why, if someone asks you why we are finding this X value, why it is important? It is very, the point where the shear force is 0, I mean this point, is very important and crucial, as it helps us identify the location of, it help us to identify the location of maximum bending moment, and this information is essential for designing process, as it allows us to account for the maximum bending moment during the structural analysis and design. So let's start to find the X distance from the left end of the beam where the shear force is 0. The method is very simple and straightforward. Just imagine or think that we are cutting the beam at X distance. So let's cut the beam and make a section of the beam up to X. So we will consider this as X, and we will include all the forces as it is. We have 23 here, reaction force, and we have UDL here of 10 kilonewton, and C is somewhere here, and we have 5, but we are not considering this one. So we are now applying the vertical force equilibrium equation, which we are very used to with the method. So let's start from summation of y is equal to 0. So we have 23 minus, we are taking upward positive and downward negative. So 23 minus 10, since it's UDL, so we will multiply the UDL force with the distance to get the vertical load. So we have 10 multiplied by X equal to 0. So it's now a simple calculation. X is equal to 10 over 10, which is equal to 2.3 meter. So the X is 2.3 meter from the left side. The point of shear, the point of zero shear is located at 2.3 meter from the left end of the beam. This is where the bending moment will be maximum, and it's a critical point to consider in the design process.